In this video, we will implement a monitoring system for the temperature of a room. This implementation will composed of the 8 mega microcontroller and an LCD and also a temperature sensor LM35. Okay. Firstly, we will begin with the code. We will use the AVR Atmega32 definitions. Also, we will include the header file of the input-output ports because we will use it in the interfacing of the LCD and also the interfacing of the LM35. Then the frequency we will use in the processor, as we know that the frequency range of the Atmega32 is from 1 megahertz to 16 megahertz. So here we will use the minimum frequency, which is the 1 megahertz. And this is the include of the delay function because we will use it, and also the stdlib.h because we will use some arithmetic operations. Now we define the two fixed variables, the enable with a 5 because we will connect it to pin 5 on the LCD, and also the register selection, the RS, on the LCD we will connect it to pin which is pin 6. Here this is 3 functions that we implemented, and we will describe it in details on this code later. And let's begin with the int main. Firstly, we will use port B to connect our LCD. The LCD have like data bits. I will show to you on the CML IDE. This data bits, we will use it to send the commands, and also from the microcontroller, and also we will use it for sending the characters that we want displayed on the LCD. So here we will use port B for this sake, and also so we will use the register, data direction register of port B. We will use it to connect to make this port B as an output, so we can connect the pins of the LCD. And also we will use DDRA, the data direction register of port A, to the analog input 0. Analog input 0 is the same pin of PA0. So we will make all the port A as an input, so we can connect our analog input, which is coming from the LM35, to our analog pins of the Atmega32. And also we will use the DDRD, port D, which contain the interrupt pins, and because we have 2 interrupt signals, the enable and the register selection, so we will use also the port D, and we will make the direction of port D as an out to send the interrupt signals to the LCD. This is the delay. We put a delay function, it's like a 50 millisecond, and then we will begin with the initialization of the ADC. Firstly, we will choose our voltage reference. Here we choose the final option, which is selecting the option that using internal the 2.56 voltage reference with external capacitor at the analog graph bin on the Atmega32. This bin, we will use the internal reference of the Atmega32, and we will connect a capacitor to the bin of the ARAF. This means that we will put a 1 on the register of the AD max on the REF S1 bit, and also another one to REF S node. If we can see this implementation also on the Simul IDE. I think now I can relate to the Simul IDE, so you can connect between the software that is written and also the diagram. So in the Simul IDE, here I put the Atmega32, and here I connect A0, which is analog bin 0, to the LM35. LM35 here we demonstrated by a voltage source, so we can change the voltage from 0 to 5 volt. This is our range يعني. And we connect this plug here, and also in the other side we connected with a electrolytic capacitor here. It's 100 microfarad and ground. So here this is simulates our LM35, and it's connected directly to a node, which is our analog bin. For the reference, we said that we use the internal reference, and also we will connect the external AREF, which is the analog reference, to a capacitor. So here the capacitor we connected to a capacitor which is 100 nanofarad, and here we one terminal we connected to the capacitor and ARF, and the other one we connected to the analog VCC bin here, as you see here in the diagram. And here we use like a fixed voltage of 5 volt. So here's the connection needed for our analog A digital converter to read the voltage value, which represent the output come from the LM35, which is in voltage, and also this is our reference. Before get back to the code also, I will show you the LCD. This is the LCD. You can bring the LCD from here, from the displays. The name is HD44780. This is our LCD. This is the data lines, which is from D node to D7. We will connect all of them to port B. It's mandatory that you connect the bits, every bit on the port B to the equivalent bit on the LCD. So here we connected B0 to D0, and B1 to D1, so and so on, until you connect D7 to B7. Okay, so you have to arrange it on this order. And the enable bin here, which is the interrupt, you will connect it to D5, and the RS, which is the register selection, you will connect it to D6. So this is all the connections that you needed. Now we will come back to the code on the Atmel Studio. So here we set the source of the voltage source, and we put our external capacitor. Then in this line we choose several parameters. The first parameter that we choose that we will divide on a factor of 1 to 8, which is represented by this parameters. in the register of the in the control register of the ADC, which is the ADC SRA, we put a 1 on all of these bits, which means that we choose the division factor, which is 1 to 8. And also we enabled the ADC by putting a 1 on the bit, which is ADN, by the shifting technique that we used before many times. And finally, we enabled the auto triggering mode of the ADC by putting a 1 on the ADAT. Then here we will use count A, which will be like an intermediate value. We will use it afterwards, and also the Shoma. Shuma, it will represent the temperature reading that we will send it to the LCD. Here we will begin with initializing the LCD itself. So we will use the function of send a command. So we can send some commands to the LCD. So we will go to the function to be more aware about the meaning of this. So we will go to the function send a command. Send a command, it take here the command, and it's begin with sending the command to port B. As we see here on the Simial IDE, that all port B is connected to the D bins here, from D0 to D7. So you will send the command in an which it's represented by an 8 bits to the LCD. So here we send the command that we will put on this argument of the function to the LCD. Okay, then this line means that the register selection, which is the RS, which is the output, comes from the interrupt signal. We will send through it a 0, which indicates that the data will be sent. It will be a command. It will be a command, not a character data. So the LCD will be ready that it will receive a command data, not a character data. Then we will enable the LCD by set the enable band to a high. So this indicates that the data is ready, and the data is ready to be read by the LCD, that we send the command, and the data should be ready to read the command. Then we will give a delay, so we will give time to the LCD to be ready. Then we will and all the command, which is represented by the 8-bit, to be sent from port B on the Atmega32 to the LCD. And then afterwards we will change the enable bit to a 0, and that means that the data transmission is ended. Finally, to ensure that all data bands are set to 0, we will put port B equals 0. So we will make sure that nothing send after disabling the enable from the microcontroller to the LCD. So this is the command function. Also, I will say what the character function represents, so we can so we can know all the functions what stands for. So here the character function, it's like the command function, but it sends characters to the LCD instead of command. After you initialized the LCD by the command, so you should send the characters that you want to display it on the LCD. So this is the focus of this function. So so we put port B equal characters. So This indicate that we will send a character. Then here we will put a 1 to the register selection. So this means that the data being sent, it will be a character, not a command, which is the other thing compared to the first function, which is send a command. And then we will enable the enable bin. We will put a high, so the LCD will be ready that we will send the data. Then we will give the delay. Then we will make the enable bin as a 0. So this will indicate that the data transmission is ended. And then also we will initialize the port B by a 0. So we will make sure that all data bins are set to 0. This function, which is called send a string, when we send more than one character, so this function it also send the character, and then it has a pointer, which is a string of characters, which will increment after you send a character, then the pointer will be incremented to point to the next character on the string. So this is all of this function elaboration. So we will go back to our main function. So to send a command, if you write on this function, send a command 0x01, that means that you will clear the screen. If you send 0x38, so this will configure that the LCD it will have two lines, and it will be 5 times 7 dot matrix characters. And also if we send this lines, which is mean 0f, this commands set that the display is on, and the cursor will be blinking, and it will be and also the character position will be incrementing after writing a character. This is the description of each command that you write on this function. If we go for the second line, we will use also the ADC control register to start conversion. So we will give the order for the ADC to start conversion, so it will convert the voltage value to the temperature. So here on the while one part here, this is the part of the code that responsible for mapping the values of the voltage that is coming from the temperature sensor, which is here prototyped by the voltage source, and to convert it to a temperature, then it will display it on the LCD. So here we use a variable which is count A that we initialized here, and then we scale down the ADC, which is the output coming from the voltage source. We will scale it down for it, so it will fit the function of the temperature values. And you want to map this voltage value to the equivalent of it on the temperature form, which is degrees centigrade. Then here I send a string, which is bakery temperature, as if we want to display the temperature of the bakery oven. Then we will send a command 0x80 plus 0 x40 plus 0. This like we are moving the cursor of the LCD. The position of the cursor, it will be here, it will be on the start of the second line, then of the LCD. Then we will move the cursor to 0x40, so it will start on the second line. So in the first line, we will write the string bakery temperature. Then we will move the cursor to the second line so we can write temperature C like this. Then here we will use the ITOA function. This is this line. It converts this function. It converts the value, which is the count A, which is the ADC over 4, to a value to be what will be stored on the character show A, which is showa, which we write it here. So it will show the temperature, and here it will send the value of the showa, which will be like a string. It will on this function send a string. It will send it character by character to the LCD. Then here we will by this space we will make sure that there will be that we will see the change between characters, between the temperatures. If we change the temperature of the ADC, so we will have like a break between each value of the temperature. Okay, after having the new value, and that's it. This is the code. So coming back to our Simial IDE. In this, we like the other projects we took before, we will write build and build solution, and then the hex file will be generated. This hex file will be loaded here on the Atmega32. You will press load firmware, and then you will load the file. So we will press load firmware, and this is our project. So we will select the name of the project.hex, and here is the code. And then this is the LCD, and this is all of the connections we set it before, and then we will okay. So here okay, I changed some of the of this, and then I played without pressing no problem. So here the voltage value, which is 0.44 volt, it gives here a temperature of 43. So if we change it here, the value, we make it like a 1.30 volt. So as you see here, 1.30 give us a 130 degrees Celsius here, which all of this, it's depending on the mapping. Yani if you will calibrate your sensor and you'll see what is the factor that you will divide the value of the voltage coming from the temperature sensor to have here like a reasonable values for the temperature. So also we can change it another time, have like this. Take time to change, and so I open and off so it will be changed faster. So here 3.48 volt, it gives us like a 255 degree centigrade. And that's it for this project, and thank you.